welcome to this deep dive from My Mind MashUps. Today, we're looking up, way up into the sky. We've gathered a really fascinating collection of information. Stuff from social media trends, the science behind what we see.
Ancient myths, yeah, and even how modern tech is changing our view of the heavens.
Exactly.
Our mission really is to unpack all these different perspectives. We want to find the most compelling insights into why the sky holds such a, powerful place in how we understand the world and ourselves.
Right. So whether you've maybe glanced up recently and thought, that looks kind of different, or you're just curious about the science.
Or maybe you feel more of a spiritual connection to it all.
Yeah, exactly. We think you'll find this deep dive really interesting. Okay, so let's jump right in. What's grabbing people's attention online when they look up?
Well, it's actually kind of incredible, the sheer volume. On TikTok, for instance, the hashtag the sky looks weird has nearly 20 million posts.
Wow, 20 million. That right there tells you a lot of people are noticing things.
They are, and wondering about them.
And it's not just like a casual thing either. You see trends like the sky looks so different. And people are actually connecting the way the sky looks to like memories of loved ones who've passed away.
Yeah, the sky looks different when someone's up there is another phrase you see. It's really quite moving. It shows how something universal, like the sky, can become so deeply personal.
It really does. It's like the sky becomes this emotional landscape almost.
Makes you wonder if looking for meaning up there is just fundamental to being human,
Then you've got the sun trend, over 62 million posts.
Huge numbers.
People talking about it looking different or feeling different. And it's a real mix, isn't it? Like nostalgia, worries about climate change.
Definitely.
Yeah.
And just general curiosity about our star.
Yeah.
It's fascinating how those personal feelings, like the sun feels different, often connect to bigger global anxieties.
Yeah, like climate change awareness.
Exactly.
And then on the, let's say, more speculative side, you get things like the no stars or moon at night trend.
Right. Often tagged with things like hashtag flat and hashtag Earth.
Which shows how some people are using these sky observations to kind of bolster alternative worldviews, sometimes conspiracy theories.
It does, and that's such a contrast with, say, discussions you find on Reddit. In places like our telescopes, you get these really genuine questions, people trying to figure out why they're struggling to see stars.
And the community chimes in with actual science, right? Atmospheric conditions, equipment tips.
Exactly. Practical stuff. Then you hop over to Vera Geography, and they're discussing, genuinely unusual atmospheric events from a scientific angle. But then you go to our parallel universe.
And it's questions like, why does the sky look different now than in 2012?
Or, my favorite, the sky looks like it is rendered by GPU, like a video game.
That rendered by GPU comment, it really says something about how our digital lives shape perception, doesn't it?
It really does. We're interpreting even the sky through this tech lens now.
And YouTube just adds another layer. You've got these like super sensational videos, crazy cloud formations.
Right next to solid educational content explaining, why you don't see stars from a plane.
Yeah, the simple reason. So it's this whole spectrum from the really out there stuff to grounded science.
And what all these online trends really show, I think, is this fundamental human need to understand what we're seeing up there, whether it's through emotion or science or maybe even speculation. We're always trying to make sense of the sky.
Okay, so we've got a handle on what's got people talking online. Now let's ground ourselves in the science. Why do we see what we see? First up, the classic question. Why is the daytime sky blue?
Right, that brilliant blue. It's mostly down to something called Rayleigh scattering. So sunlight hits our atmosphere, which is full of tiny molecules, mostly nitrogen and oxygen.
Okay.
Now, sunlight contains all the colors, but blue and violet light have shorter wavelengths. And here's the key bit. These shorter wavelengths get scattered much, much more effectively by those air molecules. They bounce off in all directions.
Like tiny pinballs bouncing off everything.
That's a great way to think about it. And it's not just a little more scattering. The intensity is inversely proportional to the fourth power of the wavelength.
The fourth power, wow.
Yeah. So blue light, around 450 nanometers, scatters roughly 4 times more strongly than red light, which is longer. Around 650 nanometers. That's a huge difference.
That definitely explains why blue dominates then. Okay, so what about sunsets? Those amazing reds and oranges. That must be different.
Totally different dynamic. At sunrise and sunset, the sunlight has to travel through way more atmosphere to reach our eyes, maybe 40 times more air than at midday.
40 times, okay.
So on that long journey, Pretty much all the blues and violets get scattered away before the light gets to you.
Ah, so what's left is the longer wavelength stuff.
Exactly. The reds, the oranges, yellows, they make it through without being scattered as much. And then you also get Mi scattering playing a role.
Mi scattering. What's that?
That happens when sunlight hits slightly larger particles, things like dust, pollution, water droplets. These tend to scatter longer wavelengths, like red, more effectively forward towards our eyes, enhancing those sunset colors, especially if the air isn't perfectly clean.
Right, particles. Which brings us to clouds. They're not just water vapor magically appearing, are they? How do they actually form?
No, not magic. It's a process called heterogeneous nucleation. Basically, water vapor needs something tiny to condense onto.
Like a seed.
Precisely. We call them cloud condensation nuclei, or CCNs. These are tiny airborne particles, maybe 0.1 to 1 micrometer across. Could be salt crystals from the ocean, dust, pollen.
Okay.
Or, importantly, pollution particles, things like sulfates or soot.
Yeah, so pollution can actually help clouds form?
It can, yeah. By providing more of these CCNs, the process starts when the air cools and becomes supersaturated. It holds more water vapor than it normally could. Then these CCNs, especially if they're hygroscopic, meaning they attract water, start grabbing onto water vapor molecules. Tiny droplets form.
And then they grow.
They grow, and they bump into each other. Merging, that's called coalescence. They get bigger and bigger until maybe they're heavy enough to fall as rain. And studies show that human emissions in polluted areas can boost CCN concentrations by like 35 to 47%.
That's significant. It could actually change cloud properties or rainfall.
It definitely can, yeah.
Now, something I've always noticed, autumn skies often seem like a deeper, more intense blue. Is that just me, or is there a reason?
No, you're onto something. There are a few reasons for that deeper autumn blue. First, the air is often drier in the fall. Less water vapor means less Mi scattering, which tends to scatter all colors more equally and make the sky look whiter or hazier. So less haze means the pure blue from Rayleigh scattering really pops.
Okay, drier air helps. What
The
else?
sun's angle. It's lower in the sky in autumn, right? So sunlight travels through more atmosphere, even during the day, which enhances that Rayleigh scattering effect.
More scattering path, more blue. Got it.
And finally, there's a contrast effect. Those bright yellow and red autumn leaves just make the blue sky seem even more vibrant by comparison.
Ah, the visual contrast. That makes total sense. Okay, we've touched on pollution, but wildfires, they can drastically change the sky. Those hazy orange days. What's the science there?
Wildfire smoke is loaded with aerosols, tiny particles. And crucially, these smoke particles tend to be larger than the usual atmospheric particles. The typical size, the number mode diameter, is around 212 nanometers in wildfire smoke, compared to maybe 61 nanometers in clean air.
So bigger particles, what does that do?
Those larger particles cause a lot of Mi scattering. And in that size range, Mi scattering is particularly effective at scattering the longer wavelengths, the oranges and reds.
Ah, so it scatters the reds towards us, while the blues get scattered away.
Sort of, yeah.
Ah.
It scatters those reds and oranges more strongly, giving the sky that distinct hue. Plus the sheer concentration of particles, especially the fine ones called PM.
PM 2.5, right.
That concentration shoots up, maybe 56 to 65% higher during fire seasons. That makes the sky hazy. And the black carbon, the soot and the smoke, absorbs some light too, reducing visibility, making everything look kind of diffuse and dim.
It creates such an eerie, unsettling effect sometimes.
Yeah.
Okay, shifting from day to night, a big complaint, especially in cities, is I can't see the stars anymore. Is that purely light pollution?
Light pollution is definitely the main culprit, and it's getting worse, fast. Globally, sky brightness has been increasing by nearly 10% per year since 2011.
10% a year, that's huge.
It is. And here's a tricky part. Satellites measuring this often underestimate the problem because they don't fully pick up the blue light from modern LED streetlights.
And blue light scatters more easily, right? We just talked about that with Rayleigh scattering.
Exactly. So that blue-rich artificial light scatters widely in the atmosphere, creating this pervasive sky glow. The result, it's estimated something like 80% of North Americans can no longer see the Milky Way from where they live.
80%. That's really sad, losing that connection.
It is. And it's not just about stargazing. It disrupts wildlife, messes with human sleep cycles by suppressing melatonin, and it's a major headache for astronomers trying to study the faint universe.
A really multi-layered problem then. Okay, so we understand the basics behind sky color, clouds, pollution effects. Let's dig into some of those specific phenomena people report seeing online. Disappearing stars, weird suns, strange clouds. What's the science say? Starting with those disappearing stars, We know light pollution's the main issue, but can you quantify that impact a bit more?
Sure. Astronomers use the Bortle scale to rate sky darkness. Class 1 is pristine, like absolutely dark. Class 9 is inner city sky glow.
Okay.
In those urban Class 8 or 9 zones, the artificial sky brightness is often greater than 18 magnitudes per square arc second, which sounds technical, but what it means is that 80 to 90% of the stars you could see under a perfect sky are just completely washed out, gone.
80 to 90%, just vanished from view.
Yeah. And like we said, add in particulate matter if PM levels get high, say over 65 micrograms per cubic meter from pollution or smoke, that can dim the remaining visible stars by another 1.5 to 2 magnitudes, making even fewer visible.
So it really is a double whammy. Light pollution hiding the faint ones, particles dimming the rest. Okay, what about when the sun looks weird?
Yeah.
Like flattened or maybe sitting strangely on the horizon? Is the sun itself changing?
Almost certainly not to the sun itself changing, no.
Oh.
That's usually atmospheric refraction.
Through refraction, like light bending.
Exactly. As sunlight enters our atmosphere, the air bends the light rays. It's like looking at something through water. This effect is strongest near the horizon because the light is passing through the thickest layer of air.
Okay, so it bends the light. How does that change what we see?
It makes celestial objects appear slightly higher in the sky than they actually are. The sun and moon typically appear about half a degree higher. This means you actually see the sunrise a couple of minutes before the sun truly clears the geometric horizon, and sunset appears a few minutes after it's dipped below.
That's wild. So the sun we see setting isn't exactly where it looks like it is.
Correct. And that flattening effect,
Hmm.
also refraction. Near the horizon, the bending is stronger at the bottom edge of the sun's disk than at the top edge. This compresses the vertical appearance. At 0 degrees elevation, right on the horizon, the sun's vertical diameter can look squashed by as much as a third.
33%. No wonder it looks so wide and flat sometimes. I've also heard people talk about seeing a green flash at sunset. Is that real?
It is real, though it's pretty rare and very brief. It's another refraction phenomenon. Because the atmosphere bends different colors of light slightly differently, blue and green more than red sometimes, just as the very last sliver of the sun disappears below a sharp horizon like the ocean.
Yeah.
Only the green light, around 500, 570 nanometers, makes it to your eye for a split second. Conditions have to be just right, clear air, stable atmosphere. Maybe happens in 15% of sunsets over the sea, if you're lucky.
Wow. Cool. Are there other weird refractive effects?
Oh yeah, you can get mirages. Inferior mirages can create an inverted image of the sun below the real one, sometimes making it look like a Greek omega symbol, the omega sun. And again, smoke or haze can dramatically alter colors, usually shifting things towards red due to that Mi scattering.
Okay, so refraction explains a lot of the visual distortions. What about the sun's actual activity? People sometimes claim it looks brighter or different because of solar flares. Any truth to that affecting how it looks to us?
Not really in terms of its visual appearance from Earth.
Mm.
The sun definitely has activity cycles about 11 years long. It produces solar flares, coronal mass ejections.
Right, we hear about those affecting satellites and power grids.
Exactly. The big X-class flares release huge bursts of energy that mess with radio communications and can cause geomagnetic storms. That's when you get auroras. These storms, rated by the K-Gup index, can push auroras way further south than usual, like down to 35 degrees north latitude in some big recent events.
So you might see an aurora where you don't expect it, which could look strange.
For sure. But the sun's visible surface, the photosphere, its actual brightness and appearance to our eyes, stays remarkably stable through these cycles. Any changes you perceive in its brightness or apparent size are almost always atmospheric. More haze, thin, high-altitude clouds scattering light, things like that. Not the sun itself suddenly changing how it looks.
Good to know. So the sun's visual weirdness is mostly atmospheric tricks. What about clouds? People share photos of really bizarre formations. Are these just rare, natural clouds?
Almost always, yes. The atmosphere is incredibly dynamic, and it can produce some truly spectacular cloud forms. Take momentous clouds, those weird pouch-like shapes hanging down from the underside of storm clouds. They look unnatural maybe, but they form from sinking pockets of cold, moist air within the cloud. Perfectly natural, just uncommon.
Okay, Momentous. What else?
Lenticular clouds, those smooth, lens-shaped, almost UFO-like clouds you often see near mountains. They form when stable air flows over a mountain, creating waves in the atmosphere downstream. Clouds form at the crests of these waves.
Ah, standing wave clouds.
Exactly. And then there are roll clouds, these long, horizontal, tube-shaped clouds. They could be associated with storm fronts or sea breezes. The morning glory cloud in Australia is a famous, massive example. These all have solid meteorological explanations, even if they look otherworldly.
It's amazing the variety nature produces. Okay, so science explains a lot of these strange sightings, but let's address some of the alternative explanations people propose. We can't really ignore chemtrails when talking about weird skies online. What's the actual scientific verdict there?
Right, the chemtrail theory. It proposes that the white trails left by airplanes aren't just condensation, but deliberate sprays of harmful chemicals or biological agents. Proponents point to trails that linger for a long time or form grid patterns and claim they contain things like barium or aluminum.
Okay, so what are those trails then?
They're contrails, condensation trails. They form when the hot, humid exhaust from jet engines mixes with the extremely cold air at high altitudes, usually above 26,000 feet or 8 kilometers, where temps are way below freezing. The water vapor in the exhaust instantly condenses and freezes into tiny ice crystals. That's the trail you see.
And why do some last longer than others?
It purely depends on the humidity up there. If the air is very dry, the ice crystals evaporate quickly, a short contrail. If the air is humid, near saturation, the ice crystals persist and can even spread out, sometimes seeding the formation of cirrus clouds.
So it's atmospheric conditions, not the plane's payload.
Exactly. Numerous studies, including detailed analysis by NASA flying research planes through contrails, confirm they're about 99.9% water ice, plus trace amounts of normal engine exhaust byproducts like soot and sulfates, which actually act as nuclei for the ice crystals to form on. There is simply no credible scientific evidence whatsoever for deliberate harmful spraying. The overwhelming scientific consensus debunks the chemtrail theory.
Okay, so contrails are just ice. What about cloud seeding? That is a real thing, right? People trying to make it rain.
Yes, cloud seeding is a real weather modification technique. It's been practiced for decades. It usually involves dispersing substances like silver iodide, which has a crystal structure similar to ice, or hygroscopic salts into certain types of clouds.
Why do that?
The idea is to encourage precipitation. Silver iodide provides extra ice nuclei to help supercooled water droplets freeze into ice crystals, which can then grow and fall as snow or rain. Hygroscopic salts attract water vapor to help droplets grow larger.
Does it work?
It can have some localized effect under very specific cloud conditions. It's often used in mountainous areas to try and boost snowpack, or sometimes for drought relief or hail suppression. But its effectiveness is still debated, and it's very dependent on having the right kind of clouds already present.
So it's not like controlling the weather on a massive scale.
Not at all. The conspiracy theories you hear about large-scale secret weather control using cloud seeding techniques are just not scientifically feasible with current technology. It's a targeted, localized intervention with limitations. You can't just create rain anywhere or steer hurricanes with it.
Gotcha. And then there's HARP. That facility in Alaska always pops up in these discussions, claims about weather control, earthquakes. What's its real purpose?
HARP, the High Frequency Active Auroral Research Program. It's now operated by the University of Alaska Fairbanks. Its actual purpose is scientific research into the ionosphere.
The ionosphere, that's way up.
Way up, hundreds of kilometers high. It's the electrically charged part of the upper atmosphere. HARP uses a big antenna array to send high-frequency radio waves up there to temporarily excite a small patch of the ionosphere. Scientists then study the effects to understand things relevant to radio communication and satellite operations.
So can it affect weather down here or earthquakes?
No. The ionosphere is far above the troposphere where weather happens, and the energy HARP transmits, while powerful for its research goal, is absolutely minuscule compared to the natural energy constantly flowing through the ionosphere, let alone the energy involved in weather systems or earthquakes. The physics just doesn't support those claims. HARP's research is unclassified and publicly published.
Okay, so HARP is ionosphere research, not secret weather warfare. What about stratospheric aerosol injection, or SAI? That sounds like something that could affect the sky.
SAI is different. It's a proposed geoengineering technique to combat climate change. It hasn't actually been deployed.
Proposed? How would it work?
The idea is to mimic the cooling effect of large volcanic eruptions. Volcanoes blast sulfur dioxide high into the stratosphere, where it forms reflective sulfate aerosols that bounce some sunlight back to space, cooling the planet temporarily. SAI proposes intentionally injecting similar reflective aerosols, probably sulfates, into the stratosphere, maybe using high-flying aircraft or balloons.
To cool the Earth deliberately.
That's the theory. Climate models suggest it could potentially offset some global warming. But, and this is a huge but, it's purely theoretical right now, there are massive scientific questions about potential side effects like disrupting rainfall patterns, damaging the ozone layer, changing ocean chemistry, plus huge ethical and governance challenges. Who decides? What if it goes wrong?
So it's very much not happening currently.
Definitely not happening as any kind of operational program. There's some very limited research, but no deployment. People often confuse the idea of SAI with chemtrail theories, but there are completely different things. One is a proposed future tech with major unknowns. The other is a misinterpretation of existing contrails.
That's a really important distinction. Okay, it seems science offers solid explanations for most strange sky phenomena and debunks the more common conspiracy theories. Now let's shift to how modern technology itself is actively changing our view of the sky. Things our ancestors never saw, like satellite mega constellations. Starlink is the big one. How is that impacting things?
Oh, significantly. Starlink and similar constellations are putting thousands of satellites into low Earth orbit. As of early 2025, Starlink alone had over 7,000 active satellites, with tens of thousands more planned.
7,000, just from them.
Yeah. And the goal is global internet, which is, a big deal, but it comes with side effects. For astronomers, optical interference is a major headache. These satellites reflect sunlight, especially the earlier models, and they create bright streaks across long exposure images taken by telescopes. This contaminates data, particularly during twilight when they're most visible. It's affecting 20–30% of some types of observations.
But they're photobombing the universe.
Pretty much. There's also radio frequency pollution. The signals they transmit can interfere with the faint radio waves astronomers are trying to detect from distant galaxies or molecules in space.
And they make the sky brighter overall.
There's growing evidence they contribute to overall sky glow, subtly increasing the background brightness of the night sky by maybe 10% or more in some estimates. This makes it harder to see faint stars and nebulae and could impact nocturnal wildlife too. Companies are working on mitigation, like making satellites darker, but the sheer numbers, especially with larger next-gen satellites, remain a challenge.
It's a massive change to the night sky environment. What about drones? They're everywhere now, too.
Drone proliferation is another huge factor. The market is exploding billions of dollars. We're seeing millions of flights globally every year for deliveries, mapping, surveillance, recreation, you name it.
And this causes sky confusion, too?
It can, yeah. Remember that New Jersey drone incident in 2024, 2025? Months of nightly sightings of, coordinated drone swarms, often unlit.
I do remember hearing about that. Caused quite a stir.
Exactly. Understandably sparked all sorts of speculation, even conspiracy theories.
Mm.
Authorities eventually identified some as commercial or recreational, but many remained unidentified, highlighting just how hard it is to track everything up there now. It even led to new drone regulations in the area.
So these new technologies are adding objects to the sky that can easily be mistaken for something else.
Precisely. And that feeds into the rise in reports of unidentified aerial phenomena, or UAPs.
Do you think there's a link?
Seems very likely. There's been a huge reported increase in UAP sightings, like over 900% between 2023 and 2024, according to some sources. And many misidentification drivers point straight at modern tech. Those Starlink satellite flares, especially from early batches catching the sun, easily mistaken for a brief, anomalous flash. Coordinated drone light shows. They can look incredibly bizarre and structured.
Like that rendered sky idea again.
Kind of, yeah. Or people seeing Starlink satellite trains lines of newly launched satellites before they spread out, and interpreting it as something unnatural. Even atmospheric refraction distorting distant planes or satellites can contribute. Add in things like noctilucent clouds, which might be getting intensified by rocket exhaust. It's a complex mix.
So more stuff in the sky, more chances for misidentification or seeing genuinely new but human-made phenomena. What are the wider consequences of all this activity? Environmental, cultural?
There are several. We've mentioned the loss of astronomical data due to satellite interference. Ecologically, the increased light pollution disrupts animals disorienting migrating birds, sea turtles heading inland instead of towards the sea. Culturally, there's the loss of the dark night sky for millions, potentially disconnecting us from something fundamental that inspired humans for millennia and which holds deep significance for many indigenous cultures.
And space debris.
That's a big one. More satellites mean more potential collisions, creating more debris, raising the risk of a Kessler syndrome cascade where orbits become unusable. Plus, when satellites re-enter and burn up, they release materials like aluminum oxide into the upper atmosphere, and the long-term effects of that accumulation aren't fully understood yet.
Wow. So our technological reach into the sky has some pretty serious potential downsides we need to grapple with. Okay, let's shift focus one more time. Let's explore the human side of all this sky watching. Why do we see faces in clouds? Why do we interpret celestial events the way we do? What's going on psychologically?
A lot of it comes down to how our brains are wired for pattern recognition. Pareidolia is a huge factor, that tendency to perceive familiar patterns, especially faces, in random or ambiguous stimuli.
Like seeing the man in the moon or animals in clouds?
Exactly. Our brains are basically pattern-matching machines trying to make sense of incoming sensory data. Finding a face where there isn't one is just a side effect of a system that's really good at recognizing actual faces. Brain scans even show the same face processing areas light up.
So it's a feature, not a bug, of our brains.
Pretty much. Then there's a related concept, apophenia. That's the broader tendency to perceive meaningful connections between unrelated things.
How is that different from pareidolia?
Pareidolia is more about seeing specific forms, like faces. Apophenia is about finding patterns or meaning in random data more generally, like seeing significance in a sequence of numbers or connecting unrelated events. This can be amplified during times of stress or uncertainty when people might be actively searching for signs or explanations.
Looking for meaning in the chaos, maybe?
Something like that, yeah. Looking to the sky for omens or guidance when things feel uncertain on the ground.
And how does social media play into this? These ideas seem to spread like wildfire online.
Social media acts as a huge amplifier and feedback loop. You get collective illusions, people start conforming to interpretations they see gaining traction. If a weird cloud photo goes viral with a certain explanation attached.
Others start seeing it that way too.
It's exactly.
Yeah.
Peer influence and the desire to agree with the perceived group consensus. Plus, algorithms often push sensational or emotionally charged content, so unusual sky photos paired with dramatic interpretations get more visibility, reinforcing those views.
Creating these online echo chambers about what the sky means. Interesting. What about the spiritual side? We're seeing things like meditative sky gazing, people blending science and mysticism.
Yeah, there definitely seems to be a current of maybe spiritual reenchantment, a desire to connect with nature and the cosmos on a deeper level, beyond just the purely scientific. Sky-gazing meditation fits into mindfulness trends. And younger generations, growing up immersed in both science and digital culture, might be looking for ways to integrate that sense of awe and wonder.
That rendered sky idea could even be part of that, couldn't it?
Well,
A modern, tech-influenced way of expressing awe or anxiety about our place in a potentially simulated reality.
it could be interpreted that way, yeah. It reflects our current context. Think about the evolution. The classic man in the moon is pure pareidolia. Now, you get theories about simulation sky, maybe fueled by seeing patterns in satellite constellations. Same basic human tendency, different cultural filter.
Or how people interpret those intense wildfire skies.
Exactly. The orange haze is scientifically explained by me scattering from smoke particles. But online, you see people linking it to apocalyptic imagery, biblical prophecy, overlaying deep-seated cultural narratives onto a real-world event, especially when it feels threatening. It shows how profoundly our minds and cultures shape our perception of even something as fundamental as the sky.
That's fascinating. Okay, let's broaden our view even further now. Let's travel back in time and around the world. How did ancient cultures and indigenous peoples understand and relate to the sky? What can we learn from their sky lore?
Oh, the sky was absolutely central to ancient worldviews. Creation myths very often started with the sky. Think of Polynesian and Maori traditions. Ranginui, the Sky Father, and Papachunaku, the Earth Mother, initially locked together, their separation creating the world as we know it.
A cosmic birth.
Right. Or in Egypt, the goddess Nut was the sky, arching over the earth god Gefrebi. She swallowed the sun god Ra each evening and gave birth to him again each morning.
Wow.
Mesoamerican cultures like the Aztecs had migration myths guided by celestial signs. And Australian Aboriginal cultures have the dream time, where ancestral beings shaped the land and the sky, leaving their stories written in the stars, like the rainbow serpent.
So the sky wasn't separate. It was integral to creation and the landscape. Did they see deities in the sky?
Absolutely. Sky deities were everywhere. The Inca revered Mamakila, the moon goddess. Inuit traditions spoke of the aurora borealis as spirits, perhaps of ancestors or animals. Aboriginal astronomy is incredibly rich. Constellations, the spaces between stars like the Coalsack Nebula, seen as the head of the emu in the sky by some groups, they all represent ancestral beings, law, and knowledge.
The emu in the sky, using the dark patches, not just the stars. That's amazing. Did they also read the sky for signs, for omens?
Very much so. Celestial omens were crucial. The Maya had sophisticated eclipse predictions and saw them as potentially dangerous times needing ritual intervention. The Aztecs recorded unusual comets or atmospheric phenomena as portents, later linked to the Spanish conquest. In Mesopotamia, Babylonian priests meticulously charted planetary movements, believing they revealed the intentions of the gods and the fate of kingdoms. Astral divination was a major part of their statecraft.
So the sky was like a divine communication channel.
In many ways, yes, and also a pathway. Many cultures connected the sky with the afterlife or spiritual journeys. The Lakota Sioux saw the Milky Way, the Wanagi Takanku, as the spirit road souls traveled after death.
The spirit road.
Polynesian master navigators used stars not just for physical wayfinding across vast oceans, think of the voyages of canoes like Hukulia, but also saw those stars as ancestral guides. Inuit myths often link the sun, Sikinik, and moon, Takik, to core life cycles and spiritual beliefs.
It's incredible how many recurring themes you see across these diverse cultures. Duality, balance, the sky as a guide, connections to ancestors and the spirit world.
And often, warnings about respecting the natural world embedded in these celestial stories, a deep understanding of cycles, navigation, and humanity's place within a larger cosmic order. It really underscores this universal, timeless human connection to the cosmos.
It really does. Okay, as we start to wrap up this deep dive, let's reflect on our modern relationship with the sky, maybe through the words of scientists and philosophers who've contemplated it.
It's a relationship that still inspires profound awe and thought. You have Carl Sagan, whose famous line, "The sky calls to us," captures that innate human curiosity,
And his pale blue dot image.
which gives such a powerful sense of perspective, humility. Neil deGrasse Tyson puts it beautifully, "We are stardust," reminding us of our literal cosmic origins. Even Stephen Hawking, exploring the deepest physics, expressed wonder at the universe's scale and perhaps ultimate simplicity.
That blend of rigorous science and pure awe seems key. What about philosophers?
Immanuel Kant famously spoke of two things filling him with awe: the starry heavens above me and the moral law within me, linking cosmic contemplation directly to ethics.
That's a powerful connection.
And Albert Einstein emphasized wonder itself, calling the most beautiful experience we can have is the mysterious. He saw it as the source of all true art and science.
So that sense of mystery isn't something science eliminates, but maybe something it refines or deepens.
I think so. The biologist J.B.S. Haldane quips the universe is likely not only queerer than we suppose, but queerer than we can suppose, acknowledging the vastness of our ignorance alongside our knowledge. And Sagan describing science as a way for the cosmos to know itself, framing our quest for understanding as something almost spiritual, a part of the universe's own unfolding awareness.
So the sky offers this dual enlightenment, understanding the mechanics and feeling the wonder.
Exactly. It pushes us to observe carefully, to measure, to understand the physics, but it also evokes that deep sense of connection, humility, and wonder about our place in it all.
Well, the sky, it really does seem to be far more than just what's physically above us. It's a constant source of scientific questions, a canvas for our imagination, a keeper of ancient wisdom, and, increasingly, a space profoundly shaped by our own technologies.
We really hope this deep dive has given you, our listener, a richer appreciation for all those layers of meaning, and maybe some clarity on the phenomena we see up there.
What stood out to you the most from all this? Did anything spark new questions as we went through these different sources?
Because this is really just scratching the surface, isn't it? It's an ongoing conversation.
Right.
We definitely encourage you to keep looking up, keep asking questions, keep exploring those wonders above.
And if you enjoyed this deep dive, please do like, share, and subscribe, or follow My Mind MashUps. That way you won't miss our future explorations into all sorts of fascinating topics.
You can find My Mind MashUps on Amazon Music, Audible, Facebook, Pocket Casts, Spotify, and YouTube.
Thanks so much for diving deep with us today.